Hello everyone, welcome to Infinite Loop and another session on data structures and algorithms. So in our previous discussion, we have seen about introduction to bit manipulation, right? Like we have seen complete concepts related to bit manipulation. What are bitwise operators and how do they actually work, right? And we have also seen some of the facts related to bitwise algorithms. Along with that, we have also seen quite a few bitwise algorithms, right? So in this session, we are going to discuss two important concepts. Okay, you can think these two things as problems or concepts, right? Like you can also see them as a coding problems, but of course it's a small piece of problem that you are going to solve, right? So let's discuss about them. The first thing that we are going to discuss is how to set a bit set a bit in any given number. Hope you understand this question, right? Let me say n is my number. Okay, so the question is very simple. You are given with some number n. Let's say I give you 5. Okay, so now your task is to set a bit in this number. That means let's say I'll say this n to be num and I'll say this to be num, and he said to set a bit, right? That means there must be some position given to set that bit. So let's say n is the position and the position to be set is, let's say, something like 2. Okay, so the question is very clear, guys. You are given with num, which is a number, and the number is 5, and you are given with a n. Here n is nothing but position. Okay, and that position is 2. So your task is to set the bit position to, that means set the bit position to, that is your task, that's it, right? You need to set the bit position to, that means if there is 0 in that position, you need to set it to 1, or if it is 1 in that position, you need to set it to 1, because setting is nothing but you're just trying to make it as 1. Okay, we have seen in our previous discussion, setting the bit is nothing but we are making it 1, unsetting the bit is nothing but we are just making it 0, right? So keeping this aside, now your task is what? Set the bit position to. Okay, so what is the number actually? Number is nothing but 5, right? If we try to represent it in bit, bitwise things, we can write something like 0 1 0 1. Hope you got it right. Here it is 1, here it is 2, here it is 4, here it is 8. 5 is nothing but 4 plus 1. Yeah, both are set, right? So this is our actual number, right? So 0 1 0 1, this is our actual bitwise representation. And if I try to write it something like this, let me make it more clear, right? I try to write it something like this. It's not an array, okay? I'm just trying to make you understand. And I'm telling this is the first position, this is the second position, this is the third position, and this is the fourth position. I'm counting the position from left side, okay? Hope you got it. Because while writing any bitwise representation, we try to write it from left, right? Like we will check from left and we'll try to see whether it's equal to that number or not. So similarly, I've wrote this in the form of something like an array. It's not an array, okay? I just wrote it to make you understand easily. Now your task is what? Your task is, let me change the color. Now your task is go to second position and make that position set. So your task is what? You need to make it as set. That's what we have done. Your answer will be what? 0 1 1 1. This is your answer. So it's pretty cool, right? Like whatever we have seen to set that bit, we are just going to that second position and we are trying to set that bit. But actually what we can do to set that bit, right? Like is there any algorithm to do this? So let's try it on. Okay. Now this is our number 0 1 0 1, and this is an important thing because we need to set that bit. You might be getting one simple clue here. If you want to set this bit, uh, you need to make sure that you need to make sure that there must be some another number. There must be some another number. There must be some another number such that that another number has bit location set at this position. Hope you got it right. You need to make sure that there is some another number such that its location at this position, I mean at this position, that bit is set. If it is so, then you can simply apply an OR operation and you can make this bit as set, right? Because 0 or 1 is 1 only, right? Hope you got it. I made it clear, guys. What I'm telling is your number is 0101, right? So what I'm doing is my idea is to set this position. I mean to set this 0 to 1. Now what I'll do is I'll try to write here 1 and I'll make remaining things as 0. Hope you got it, right? And what I'm doing, I'm simply applying an OR operation. What will happen? 0 or 0 is 0. 1 or 0, 1. 0 or 1, 1. 1 or 0, 1. Now you can clearly see we got our answer. We know what is the answer, right? We are just making it as 1. Your answer is 0, 1, 1, 1. You can see we got our answer. So the algorithm is very simple. Like the idea or the intuition behind this problem is very simple. You need to find another number. Okay, let me say a num. A num is your another number. Num is your actual. Okay, num is this one number, and a num is another number, and you need to find that another number such that the another number has set at that particular bit location. That means if here bit location position is second, right? So I'm making sure that the second position is set here. If it is given 3, then I'll make sure that this is set and this is 0. If it is set like bit location 4, then I'll make this is set and this is 0. Hope you got it, right? So the funda is very simple, guys. I'm trying to make sure that I'm creating a completely new number, okay, such that that new number has bit location set at the bit position, at that particular bit position, okay. So what I'm doing is I'm trying to create a random number, right? Random number such that the bit location given, okay, the bit location given in the question, such that the bit location given in the question is made as set. That means it is made as what? A set bit. Set bit is nothing but what? It is nothing but 1, right? So let me try to make you more clear. If it is given as n equal to 2, then what is your a num? That means what is the number that you need to take? Second position. That means second position will be 0, remaining second position will be 1 and remaining will be zeros, something like this. If n is given as something like 4, then what will be your a num? It is something like fourth position will be 1, remaining will be zeros. Hope you got it, right? N is your position and we are trying to make an a num such that it has bit location set at this location. Now why we are trying to make this? Because our original number, whatever is there, num, right? Whatever the original number is there, we are trying to apply an OR operation with the original number. That means num. Such that what happens if you apply OR operation between this num and this a num, then you are going to get your required answer. It is as simple as that, right? Now let me tell you with another example, guys. Let me try to draw a line here. Let's say n is given as 6 and sorry, num is given as 6 and your n is something like 3. Okay, what is 6? Can you write it in bitwise representation? 6 is nothing but 4 plus 2, right? So we can write something like 0 1 1 0. Hope you got it. 0 1 1 0. This is your 6. Third position is nothing but this is the third position, but it is already set, right? But it is already set. Then what to do if it is already set? If it is 0, we are trying to make it as 1. But if it is 1 already, then what we need to do? We need to make it as it is. So let's try to see. For 0, we have used some algorithm. What is that algorithm? We are trying to find out the a num which has the bit location set at that nth position, and we have applied an OR operation. Let's try to do the same algorithm here also, because here you can see the bit is already set. Here bit is already set. Then what you need to do? Let's try the same approach in previously what we have seen. You're going to take this number, original number, okay, which is your num, and you need to find an a number. What is your a number? A number must contain 1 at this position. That means this position. Remaining all will be zeros. Now what I'm doing, I'm applying an OR operation. What will happen? 0 1 or 1 is 1, 1 or 0 is 1, 0 or 0 is 0. You can see you got your answer. Nothing we have done, guys, right? Here there is no change in the position, right? I mean no change in the set bit because the bit is already set. So you can clearly see this algorithm is working, like taking the num, I mean taking the given num and trying to find out a num, and we are simply applying an OR operation, right? This is working, this is working. Now, the major question you will be getting, how to find out the same a num. Okay, the major question is how to find out the a num. We have seen in detail discussion, right? We know what is num. We are trying to find out a num, and we are doing OR operation between num and a num, right? That is going to give you your answer, and we have seen how we are getting it. Now the idea is how to find this a num. If you know how to find this a num, then simply OR operation is very easy. You will just write something like this, right? A num or a num. This is your answer actually, right? Something like this. Now your question is how to find this a num, right? Now I'll tell you one of the simplest approach to find the a num. You can clearly see that a num is nothing but it is a bitwise representation, right? It is a bitwise representation. This is a simple thing that you know, bitwise representation. And one more thing is it contains only one. It contains only one. Remaining all are what? Remaining all are zeros. I mean remaining all positions are zeros. Hope you got it right. We know that it contains only one at some specific location. What is that specific location? That is nothing but n, right? So your enum is simple. It is a bitwise representation and it contains only one. That means in this entire bitwise representation, you will have only one. Okay, hope you got it. And remaining all the positions are zeros. Now you might be getting one funda. There is only one. That means what? You can write, you know the representation of one. This is what? This is what? This is a bitwise representation of one, right? Now what we can do, guys, we can simply shift this one, right? We can simply shift this. We can simply shift this one to nth position. That's it. That will give you a num. It's very simple, right? Now what I'm doing is I have initially this is my one, right? This is the representation of one. And what I'm doing is I'll do left shift one time. Then what happens? It becomes 0 0 0 1 0. Simple, guys. We have left shifted this to one time. Again I will do left shift for one time. Then what happens? 0 0 1 0 0. Simple. We have left shifted, right? Again I'm left shifting. What happens? Becomes 0 1 0 0 0. So you can clearly see that we are left shifting this number 1 for many times, right? For many times. Instead of doing many times, do it for n times. If I do it for n times, I mean based on the n value, then my 1 will be at nth position. That's it. That brings your answer. Now if I left shift this one for n times, then my 1 will be present in or at nth position, right? So initially my 1 was something like this, somewhere 0 0 0 0 0. If I take a 32-bit representation, my 1 is at extreme this position, right? And if I want to place it at some particular position, I will do what? This is nothing but 1, right? I will do 1 left shift and that's it. This is your enum. Now you got your enum, right? What is enum? 1 left shift n times, because that is going to give you your enum actually. Because your enum only contains what? Your enum contains only bitwise representation and it contains only one. Remaining all positions are zeros, right? I mean remaining all things in that bitwise representation are zeros. So we got to know how to find enum. Now if you got to know how to find enum, what you need to do? You need to do num or enum. That's it. That is your answer. That means num or 1 left shift n times. This is your final answer. Now you can see initially in the question I have given num and n, right? These are your, you can say, inputs, and you can see output also. I have made it something like in terms of num and n. I've used operators, or operator and left shift operator. So you can see how easily I have done it, right? This is the simple thing that we can do to set a bit in any given number. Hope you got it right. Simple. Here we are given with a number num, okay, and we are given with a position n, okay, and we need to make second position set in this number 5. To make that second position set, I mean to make that second position as 1, we are trying to find out another new number or another number, that is a num, and we are making that a num at that nth position as 1, and we are making that a num at that nth position as 1, and simply we are applying an or operation, and we got to know that we got our actual answer here. Here we have seen here the bit was unset, that's why you got correct answer. And we have also seen one more case, like here you can see already the bit was set, and you want to make this third position as set because it was already set. Then what's the use of doing it again, right? But we are applying the same algorithm again, and we got again the same answer. That means this algorithm is actually working, right? So that is the idea of this question, guys. Okay, I'm not trying to make it complex. It's very simple, right? Num, and you're applying an or operation, one left shift n times, and we got to know this is nothing but a num, right? This right hand side is nothing but a num, and this left hand side, you know it. So this is the idea of setting a bit. And the second part of this session is how to unset a bit. If you know how to set a bit, then unsetting a bit is not a big deal for you. You might have already guessed, right? I will say num as something like 5, and I'll say n to be something like 2. What is num? Num is nothing but 0, 1, 0, 1, and n is 2. That means, let me try to take another example. Instead of 2, I'll say something like 3. Okay. So you can clearly see 5 is nothing but something like this. You can write something like, you can make it easy, right? Instead of doing like this, you can simply write like this. This is the first position, this is the second position, this is the third position, this is the fourth position, and you want your third position, that means this to be what? To be unset. You want third position to be unset. Now what can I do? I should make this as 0, and your answer will be what? 0, 0, 0, 1. Simple. This is your answer. Now what can I do to make it? I mean, what can I do to make this bit unset? Let's try the same approach, guys. Take num, which is 0, 1, 0, 1, and take a num. A num is nothing but what? A num is nothing but at this position. I mean, this is third position, right? Third position. So at this position, make as 1. I'm making as 1, remaining all zeros. But wait, don't apply or operation here, because if you apply or operation here, this bit will be I mean, we are making this bit as set, but our idea is to make this bit as unset. Of course the bit is set here, but our idea is to unset this bit, I mean this bit. That means this 1 must become 0. Wait, you could have got it. If 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 I try to make this as 0, let's say this as 0 and remaining all as 1. Hope you got it right. I'm trying to make it more simple. Let me say, instead of doing this, let's take the same thing, 0, 1, 0, 1, and instead of 0, 1, 1, 0, 0, I'll try to write 1, 0, 1, 1. You would have already guessed what I have done. I have simply flipped all the bits. That means instead of 0, I have made it as 1, instead of 1, I have made it as 0, again instead of 0, I have made it as 1, again instead of 0, I have made it as 1. Simply flipping all the bits. If it is 0, I'm making it as 1, and if it is 1, I'm making it as 0. Now, what I'm going to do, I'm going to simply apply an AND operation. Let's try to see will it work or not. 0 and 1 is 0. 1 and 0 is 0. 0 and 1 is 0. 1 and 1 is 1. I'm applying AND operation, guys. Hope you got it. AND is nothing but if there is 1 and 1, then only it is 1. Otherwise, it is 0 in all the cases. We know this simple thing, right? Like we have seen in the previous bitwise operators videos. Wait. I got my answer, guys. So it is as simple as that. What we are doing, we are applying an AND operation, but we are flipping all the bits. Flip the bits apply and operation, apply and operation. Now why we are doing this? You might be getting a question. Because if I don't flip the bits, then whatever the algorithm that I'm following here, it will be similar to setting a bit. But our idea is what? Our idea is to unset this bit. If I want to unset this bit, I need to make sure that the opposite end, that means anum, should contain 0. You can clearly see the opposite end, that means the anum should definitely contain 0. If it is 0, then I know that 1 and 0, or anything and with 0, whatever it may be, anything and with 0 will definitely give me 0. If it is giving me 0, then I'm trying to make it as unset. Hope you got it right. My idea is to make this position as unset. To make this position as unset, I need to find anum such that this position has 0. And if I make it 0, you know that whatever the number present at this location, at this position given, like third position is given at here, whatever the position number present at this position, you have here 0, and you're applying an AND operation with 0, it will definitely give you a 0 only. So here we are somehow making it unset. Hope you got it right. So the idea is very simple, right? What we are doing, we are taking num, we are taking anum, but this anum is here not of anum. That means we are flipping all the bits. So your answer is what? Num and operation, not of anum. This is your actual answer. But you know what is anum? Previously we have seen what is anum. Anum is nothing but left shifting 1 for n times. So this is your final answer, guys. Okay. Hope you got it right. So the idea was very simple. Given num, and you want to make the num at this position as unset. If you want to make that at that position as unset, then the other end, that means whatever another number that you are taking at that position, it must not contain 1, it must contain 0. Why? If it contains 0, then we can somehow apply AND operation with 0 and make it as 0, because if you apply AND with 0, whatever the left hand side it be, you are applying AND with 0, it will definitely give you an output of 0. That means we are somehow trying to make it as unset. So that is the idea. We are doing the same thing, like we are taking 1 and we are left shifting n times. This is only the number, right? 0 1 0 0. But we are trying to flip all the bits. That means we are applying an not operation. That's why it has become what? 1 0 1 1. That means 0 has become 1, 1 has become 0, 0 again has become 1, and 0, this 0 has become as 1. And simply you are doing an AND operation which is giving you the result. That is your answer. Hope you got it right. So in this session, guys, we have seen two important concepts: how to set and unset a bit. Remember, guys, these two concepts will help you in many bit manipulation problems, especially coding problems that you face in your interviews or whatever it may be. If you know how to set and how to unset a bit, then that problem will be very easy for you. That will be a piece of cake for you. Okay. So hope you got it right. How to set a bit, how to unset a bit. Like simply we are taking the question. We want that position and we want something at that position. I mean, if to set a bit, we want at that position as 1. And if we want to unset a bit, when we want at that position as 0. After getting 1 or 0 at that particular position, we are simply applying, here we are applying OR operation because we want to set that bit, and here we are applying an AND operation such that it unsets that bit. So it is as simple as that, guys. Okay. So hope you guys liked my session, guys. It was very informative video, right? So thank you for watching this session. If you have any doubts, please comment. Okay. And if there are any corrections that I have to make, or if there are any problems that you face with respect to my explanation, definitely please comment. Okay. Thank you for watching, guys. Please try to like this video and try to share it to your friends, and definitely don't forget to subscribe to this channel, as I am new to this channel, YouTube channel. So please try to motivate me, guys. Thank you.